All right. This is actually funnier if you knew German, because the square root of 81 is 9, but the German word for no is 9. So yeah, there's humor there somewhere. All right, you will need to be familiar with this guy right here because you're going to be asked about pieces and parts of this. For instance, customers at Food Squirrel, not to be confused with Food Lion, spent an average of $150 during a typical shopping trip. That is their mean, and then standard deviation of $32.50. So now, spending at least $175, that is not cleanly going to fall under this guy. So what we are going to have to invoke Desmos in this. 150 and 32.50. So what we're going to do here is we're going to go over to functions and distribution and normal distribution. And we said the mean was 150 and the deviation was 32.50. Now, they asked the question, what percentage of customers spend at least 175? That's 175 or more. So we're going to say 175, and the maximum is infinity. Now, from that point, that is 22%. Now, here, that would be something like doing this, and that would be 22% that way. That would fall somewhere between the mean and the first standard deviation. But anyway, so 22% is what we found out for these guys. Spend at least $175 when they go shopping. Now, what percentage of customers spend between 100 and 150? We go back to Desmos, and here we put in 100 to 150. And in between those is 43.8, about 44%. We go back here and say about 44% of them will spend in that range. All right, Acme watch batteries produces batteries that last an average of 1,000 hours, standard deviation 80. If they produced 700 batteries yesterday, but have to replace batteries which stop after 900 hours, how many can they expect to replace from yesterday's production? So first of all, you need to figure out what is the percentage that would stop after only 900 hours. Now, it's probably easiest to go back to Desmos and do 1,080. And then we want ones which stop after 900 hours. So we want basically 900 and less, right? Because if they last longer than 900 hours, it's okay. It's the ones that stop at 900 or less. So we go back here and we'll delete that part. And when I click off of it, it goes back to negative infinity. That's kind of a default setting. And then here we'll put 900. And it is 10.56, even 10.565 percent that will fail before it reaches 900 hours. So we come back here and we say 700 times 10.565, which I'm going to go back here and say 700 times 0.10565. And that gives me 73.955. Might as well say 74 batteries are expected to go bad out of that batch? All right. You're expecting to replace 74 batteries out of that bunch. All right, number next. Z-scores. This one is mean score of 78, standard deviation of 5. If his raw score was 70, find his Z-score. All right, your standard formula is Z equals X minus mean over standard deviation. So in the case of number 4, we're going to plug in, we don't know what the Z is, that's what we want. X was the score, he got a 70, the mean was 78, and the standard deviation was 5. Which by the time I subtract, I get a negative 8 over 5, which is negative 1.6 for a Z-score. Yeah, that works. All right. And on the other side, if we're told that the Z-score is 2.4, we don't know his raw score, but we do know the mean, we do know the standard deviation. Multiply both sides by 5, I get 12. Add 78, I get 90. 90 minus 78 is 12. 12 over 5 is 2.4. Okay. Now, determine which underlined number represents a parameter and which one a statistic. Remember, parameter is you're dealing with the entire population. And statistic is you're just dealing with a sample. All right, according to PGA, 84% of all pro golfers swing right-handed. That sounds like all of them. That sounds like a parameter. According to USA Today, and that's your first clue, USA Today always does polls which involve samples. That is a statistic. Recent poll, this is a statistic. U.S. Census shows that 71% of Americans at least own one car. Census, that tells you this is a parameter. Okay, YMCA checks the pH levels in its pool every hour and calculates a mean for the day. The mean should be 7.5 with a standard deviation of 0.3. Now, if the pool was open 23 days this month, what would be the standard deviation of those means be? The standard deviation of the means. All right, so here, your standard deviation is equal to sigma over square root of n. That's right, that is x bar. And your standard deviation was 0.3, not 0.03. Over the square root of 23 different days, 23 individual means. And when we go to Desmos, 0.3 divided by 0.3 divided by the square root of 23, I get 0.06255. Okay. And the key word there was this the standard deviation of means plural. Now, I switch to this one. All right, in this place, 42% of NLO students preferred M&M's plain, standard deviation 4%. Asked a sample of 100 students, and standard deviation should be. Now, in this particular case, 42% is considered the mean for this group. But when we start talking about standard deviation of this sample, then we're going to have square root of p times 1 minus p over n. Now, in this particular case, p is 42. So we're going to have 0.42 times 1 minus 0.42, and n was 100 students. Now, 1 minus 42 is basically 58. And that's what I'm going to punch in the calculator. All right. I'm going to go square root of 0.42 times 0.58 divide by 100. Now, it does not matter whether they're both on top. Your order of operations is okay here. But basically, it says 0.049 and some change. We're going to go back here and say 0.049 is going to be my standard deviation of this sample, of this parameter. And one of the things about this category that makes it different, well, I won't get into that. All right, down to the matrices and the vectors and the complex numbers, and we're done. So this would be, you would definitely, first of all, distribute the 5. I'm going to distribute the negative with the 5. So that's going to give me a positive 15, a negative 10, a negative 30, and a negative 25. And that way I can add these and not have to worry about signs. So negative 4 plus 15, negative 6 plus negative 10, negative 5 plus negative 30, 4 plus negative 25. And that is going to be what that looks like. And again, we can add and subtract these so long as they are exactly the same dimensions, the same rows and columns. Here we have a 1 row by 2 columns. And by the time I finish distributing the 5, well, it's not 20 minus 30. It's 20 and negative 30 minus 6 and 1. Now here I am going to have to watch my subtraction. 20 minus 6 is 14. Negative 30 minus 1 is going to be negative 31. All right, multiplying the matrices. So again, we're talking about going across, and we're going down. Now, the going down part is easy because this is only a 2 by 1. Well, think about this. This is a 3 rows by 2 columns. This is a 2 rows by 1 column. And so what is our, the 2's match, but look at what our result is going to be a 3 by 1, 3 rows and 1 column, which means we're going to do basically this. And we're going to have 6 times negative 6 times negative 2 plus 0 times 6. We're going to have negative 3 times negative 2 plus 5 times 6. We're going to have negative 6 times negative 2 plus negative 6 times 6, which is going to be 12 plus 0 and 6 plus 30 and 12 plus negative 36. And so that is going to create 12 and 36 and negative 24. All right, one more set, just to give you a little extra practice. All right, so we're going across and we're going down. And my 2 by 2 and 2 by 2, these match, so I can do this. This is what my answer is going to look like. So I'm going to have and you've seen me do this before. I'm going to have a 2 by 2 as a result. I'm going to have negative 3 times 5 plus 3 times negative 5. And then over here, I'm going to have negative 3 times 4 plus 3 times negative 5. Here, I'm going to have 2 times 5 plus 1 times negative 5. I'm going to have 2 times 4 plus 1 times negative 5. All right, which means I'm going to get negative 15 plus negative 15. I'm going to get negative 12 plus negative 15. I'm going to get 10 plus negative 5, and I'm going to get 8 plus negative 5, which means ultimately I get negative 30 and negative 27 and 5 and 3. All right, which ones do not work? A is a 2 by 2. H is a 3 by 2. Now, that's it right there. Now, it makes it sound like there might be more than one, so we'll check. F is a 3 by 2. And C is a 2 by 2. That one should work. F is the 3 by 2. B is the 2 by 3, so that one should work. We'll get a 3 by 3 as a result. And then B and F, B is a 2 by 3, and F is a 3 by 2, which means we'll get a 2 by 2 as a result. All right. Find the magnitude. This is basically x sub 1, y sub 1, x sub 2, y sub 2. Distance formula, 10 minus negative 2. Watch those signs. And then 15 minus negative 1. 10 plus 2 is 12 squared. 5 minus negative 1 is 5 plus 1, that is 6 squared, which is 144 plus 36, which is square root of 180, which we could pull a 36 out of that. 36 times 5, which would make this 6 root 5, if we needed to go that way. All right, find the resultant vector. Let's see now, this is going to mean, let's change colors. Let's go purple. All right, 3 times negative 5, 7, minus 2 times 3, 2. So this is going to be negative 15 and 21. And then I'm going to put the negative inside of here. That's going to be negative 6. Negative 2 times 2 is negative 4. So by the time I combine them, negative 15, negative 6, I get negative 21. 21 and negative 4, I get 17. Here I have a negative 5, 7. And I have a 5 times 3 and 2. So that's going to be a positive 5 and a negative 7. That's going to be a 15 and a 10 on the inside, which means I'm going to wind up with a 20 and a 3. All right, down to complex numbers. All right, 3 plus 5 is 8, plus 7 is 15. 4i minus 6i is negative 2i, minus 8i is negative 10i. You just got to watch your signs. Remember that that negative distributes on both of those. All right, negative 4. We're going to do it that way. Negative 4 plus 2i. Negative 4 times negative 4. Negative 4 times 2i. 2i times negative 4. 2i times 2i is 4i squared. All right, so we come over here and we do 16 minus 16i, that's 8i and 8i together, and then plus 4i squared, that becomes a minus 4. 16 minus 4 is 12. And remember that the I term has to come last. This one is more boxing of the same. 5 plus 4i, negative 3 minus 2i. Negative 3 times 5, negative 3 times 4i, negative 2i times 5, negative 2i times 4i. That's going to leave us with negative 15. Negative 10 and negative 12 make negative 22i. And then minus 8i squared. Now that I squared is going to become a negative 1, which by the time we multiply it times negative 8 times negative 1 becomes a positive 8. Negative 15 plus 8 is going to leave me with negative 7. Okay. And the last one, simplify this. What we're going to have to do is to multiply by the conjugate. And well, the top one will definitely need to box. 5 minus 2i, 3 minus I. That's going to give me a 15, a negative 6i, a negative 5i, and a positive 2i squared, which is 15 minus 11i plus 2i squared. The I squared turns it into a negative 2, and 15 minus 2 is 13. And then down here we have a squared and b squared where there is an understood 1. This is a 1i and a 1i, so we're really saying 3 squared plus 1 squared, which is 9 plus 1, which is 10. That is what that's going to look like.